inequality statements. So we're going to do word problems again. So for those of you that might be struggling, this is a good example to go through this. Okay? But now we're going to notice that we're going to have things that involve inequalities. So let's take a look at some of our key words. Let's take a look at some of our key words. Can somebody read our statement here for us? Nice and loud. Tori May, go for it.
Oh no, I'm waiting for it to load.
It's fine. Can you?
Identify inequality word problems when you see phrases such as at least, at most, no more than, or no less than.
So if I said, for the first quarter, I want you to have at least an 85. That means an 85 or above. So it would be x is greater than or equal to 85. So when you see these terms, we want to make some sort of relationship. So let's write all four down. So let's write at least, oops, at most, no more than, and no less than. Now I don't want you to memorize these, but I want you to think about logically what's happening. So again, a moment ago I said, if you want an 85 or at least an 85, it means 85 or above. So it's greater than or equal to. That's what this first one means. Greater than or equal to. If I said, at most, I want you to only have one missing homework this quarter. So you have either one missing homework or none, or less, right? So that would be instead of greater than or equal to, less than or equal to. Again, if you have at most 7 ways, or who plays video games here? Halo or Call of Duty? Anybody? Okay. You know how you have the button configurations? You could have like southpaw, you can have the different setups for your joystick. There's probably like 5 of them, right? Different layouts. So you'd say there are at most 5 different layouts you can choose from. Okay, at most, there are 5 of them. So at most means there's that many or less. So it's less than or equal to. Okay, at most you should have 3 slices of pizza. Anything more is a little bit too much, right? So it means you have 3 slices or less. So again, less than or equal to. That's what at most means. Which is kind of misleading, right? Because you hear the word most, you think a lot, but it means less than. When you hear the word least, it actually means greater than. These next two, though, no more than. If I have no more than 5 brothers, I have 5 brothers or less. So this one happens to be less than. And the last one would be no less than. If I want you to have no less than, I don't know, no less than 3 different group members this quarter for problem sets. No less than means you should have 3 or more, right? 3 or more. So greater than or equal to. So when we see these terminologies in the word problems, we have to think about what's going on in the problem. If you're asked a problem, which we're going to look at in a minute, where you want to make at least $20, you want $20 or more as a profit. So greater than or equal to $20 for your profit. So we're going to see how these come up in word problems. Okay, can I get somebody to read this one, please? Example 1, Ida.
A store is charged $5.50 each for calculators and the delivery is charged $25 for the order. If the store sells the calculators for $8 each, they must be ordered and sold to produce a profit of at least $86.
So we've got a problem where we're buying an item, it costs us $5.50, but then we're reselling it for $8. So clearly we're making some profit margin, right? Now, the issue now we have to also consider is that there's a $25 surcharge to buy it because you have to get a delivery to your store. So maybe you buy like 150 calculators, but it's a $25 flat fee to get them delivered to your store, and then you sell them. So you have to make up the $25 profit margin, and then from there, you can make profit on each calculator you sell. So for a while, the first few that you sell, you're not making any money, right? Because you're making up for the $25 it cost you. And then once you make up for the $25, after that, you're making, what is it, $2.50 per calculator? Okay? So we have to think about how many we'll need. Now, you can do this in your head. Okay? You can do this by looking at the problem. But I want to solve it algebraically so we can see how to do these problems. So what are we looking for in this problem? What are we trying to find out?
How many calculators will get?
How many calculators? So let x equal the number of? Now, we are assuming, obviously, as it says here, that the calculators are all ordered and they're all sold. You have no leftover inventory. Okay? If you had leftover inventory, it'd be a whole other issue. Okay? We have to talk about changing the price because it's leftover inventory. But here, you're ordering this many and you're selling all of them. Now, how would I define profit? How would I define profit? You can define it in words, in variables, but anyway, how would I define profit?
When you make more money than what you bought it for.
Exactly. So the money you make minus the money you put out, you spend. So we could say that profit is defined as the income you get minus the cost. And I'm just going to use these three letters. Okay, I'm going to say profit is defined as the income, the money you bring in, minus the cost, the money you spend. That's what profit is. Some people say revenue and stuff, use different terminology in economics, but for the sake of this class, let's say the income you get minus your cost is your profit. At the end of the year, your parents get a W-2 statement, which tells them what their gross income is, how much money they made at their job this year. Well, that's not what your profit is for the year, right? The money you can profit and save in the bank is your income minus whatever it costs to have a family, right? To raise a family, to have a house, or to live in an apartment somewhere, or whatever it may be. So you have to think about profit as the money you save, okay? Now, we want our profit to be what? We want our profit to be what?
At least 86.
At least 86. So it could be 86 or it could be 87 or anything what? Anything greater than 86. So we could say that this must be greater than or equal to 86. See how I changed the symbol suddenly from equals to greater than or equal to? Because of this problem. Sure, profit's definition is income minus your cost, but I want the income minus the cost to be greater than or equal to 86. So that's how this becomes an inequality word problem. Next. We're told that our income, how much money do you get for each calculator? How much do you get for each calculator?
$2.50.
Not the profit margin. How much do you actually get before the cost?
$8.
$8. You're right. $2.50 per calculator. But for the sake of this, I'm just going to say 8x for now. That's what the income is. And you'll see, Austin, where yours is going to come into play. Because it will. Then, what we have to subtract here is the cost. What does it cost per calculator?
550x plus what?
Not 550. Oh, yeah, 550. I'm sorry. Yeah.
Wait.
Jeez, you're right.
550x plus 25.
Good. Very good, Arthur. Sorry. I was thinking 250. So each calculator costs you $5.50 plus the $25 surcharge for the delivery. So if we, in a moment, we're going to simplify this, we will get back to the 2.5x, which is where Austin started talking about, and that's exactly right. But just to show the work, okay, just to show the work. Please remember to distribute the negative sign here. Again, your income per calculator is $8 per calculator, but you have to subtract your cost. Your cost is $5.50 per calculator plus the $25 surcharge. So let's go ahead and write it like this. So I distribute the negative 1 on the outside. There's really a negative 1 here. Distribute it to both terms. Then we subtract the x's, giving 2.5x. And then what do I do at the end? Add 25. What do you get? What do you get when you solve this, when you divide by 2.5?
44.4.
44.4. So David, tell me what's the answer actually?
Well, then it would be x is greater than or equal to $44.40.
Be careful. I want him to fix himself real quick before I go on. What was x defined as?
Oh, calculators.
So can you have, so how many calculators do you have to order?
At least 44. Well, 45.
Yeah. Again, think about this for a moment. Can you order 44 and 4/10 of the calculator? So if you have to order at least 44.4 calculators, it means you got to have at least 45. Because if you order 44 calculators, you're just going to miss your profit margin. You're going to be just under it. And you can try that. Take the 44 and plug it in for x up here, and you'll see that you'll be just under 86. But if you order 45 calculators, you'll be a little bit over 86, which is fine. because you need greater than or equal to 86. Sometimes you're not going to get the exact amount you want as profit. But are you going to argue if you get more than what you want? No, you're never going to argue that. So you need to order at least 45 calculators. Okay? At least 45. This is what makes some of these problems tough. At the end, you need to use common sense and logic to come up with your answer. Now, you noticed a moment ago that I prompted David by saying, what was given you? What was X defined as? That's what you need to do. In this problem, it's very tempting to say $44 or use a different unit. But if you go back to your let statement and see that X was defined as the number of calculators sold, you can clearly know that your final statement will be some units of calculators. Okay, some units of calculators. Number two, find 4 consecutive even integers whose sum is between 20 and 30. So what are we looking for? What are we looking for in this problem?
3 even, like, consecutive numbers.
4 even consecutive integers. So what would our let statement be? Who can tell me what the let statement would be for this problem? What would the let statement be? Francis? Yeah, let x equal the first integer. First even integer. Now, some of you made this mistake on your test. If it's an even integer, what's the next even integer defined as?
Plus 2.
X plus 2. And then, keep going, Worth.
X plus 4.
And?
X plus 6.
And I stop. Okay? And you can write it like this, right? Please use shorthand. Okay, those quotes mean repeat everything above. So the first, second, third, fourth even integer. And we know that the sum of these integers is between 20 and 30. Between 20 and 30. So it can't be 20 and it can't be 30. If it could be 20 or 30, you would say between 20 and 30 inclusively. Meaning it could be 20 or it could be 30. But in this case, it's something between 20 and 30. So how can I write some sort of statement next? What can I write next?
You do x plus 2 plus, or you can start off with 20.
Yeah.
Okay.
And then is less than x plus 2 plus x plus 4 plus x plus 6. And then is less than 30.
Very good. So what Tori May has done is she set up like a boundary. She has said the following. Take a look at the board if this is confusing, please. She has said the following. She said, we are at 20, but our sum needs to be somewhere between 20 and 30. So here's the sum, and it's between our lower boundary of 20 and the upper boundary of 30. She did not say less than or equal to, because it can't be 20 or 30, because it doesn't say the word inclusively. You can't include those. Collect your like terms, please. That's what you should get in the middle, right? Yes, no, maybe so? Just nod your head, please. Or no? Now, at this point, what I want to do is this. I don't want to solve this by breaking it up into 2 separate parts. I'm going to show you how to do it all together. It's quite simple. Normally, if you said subtract 12 from this side, just subtract 12 from all 3. So let's do it that way. $20 minus 12 is 8. 4x plus 12 minus 12, those cancel, gives us 4x. 30 minus 12 is 18. Is that clear? So it's like a 3-part equation. Just do everything to all 3. So I would divide by 4 to get rid of this, so I do it for all 3 now. Okay? Because you would divide by 4 to get x by itself, divide by 4 in all 3 cases. Now, here's where it gets difficult. The problem wanted us to find 4 consecutive even integers. And we're told that our first even integer, x, our first one, is somewhere between 2 and 4.5. What even integer or even integers is between 2 and 4.5? Austin?
4.
Just 4. Just 4. 2 is not included in the answer set because it's not equal to. Again, it's not less than or equal to. The only even integer between 2 and 4.5, not including the endpoints, is 4. So x must be 4. So what are my 4 integers? 4, 6, 8, 10. And if you add them up, you will get a number that is between 20 and 30. It happens to be 28. Okay? So those are your 4 even integers whose sum is between 20 and 30. And this is tricky, and I purposely did this, and I made sure that this came out to be even. Do not include this as your answer. Some people say 2, 4, 6, 8. But if you add 2, 4, 6, 8, you get 20. We want it to be between 20 and 30. 20 is not between 20 and 30. 20 is just on the outside. Okay, it's not between them. Let's take a look at the next one. This said, whoops, hold on. So the 20 miles at a rate of 25 miles an hour in the first leg of the trip, using D equals RT. If you solve for time, it's D over R, right? And D over R is 20 over 25, which is about...
0.8.
Yeah, or exactly 0.8. 0.8 hours. Okay? That's the first part of the trip. It takes 0.8 hours to complete the first leg of this trip. If that is true, how much time is left for the second leg of the trip? Again, it takes 0.8 hours to complete this first leg of the trip using our formula. We plug in 20 over 25 here for D over R. How long would it take for the second half of the trip, Ida? Yeah, we have at least, or at most, 1.7 hours left. Okay? So the time over here needs to be something less than 1.7 hours to keep under the 2.5 hours total. So I can drop this piece of information now. I don't really need it anymore. Okay? Now, what was my expression for time when I solved generically? A generic solution for time is what? Francis? D over R. So in part 2, and I'll use red, D over R, which is time, needs to be less than 1.7. Again, think about this for a moment. D over R is what time really is, distance over rate. So the distance in part 2 over the rate in part 2 needs to be less than whatever the time was we had left, which is 1.7. This is one of the few times that I'll actually plug in the number. Okay, just to show you what's going on. And don't you know the distance already? So you could flip-flop these two, remember. Okay, you could switch these two and solve for R. Because 1.7 is really over 1. This is really over 1, so it's really a proportion. So you could switch these two. So what you get is D over 1.7 is less than R. What was D? D was 30. So let's put a 30 in there. Okay, 30 over 1.7 is less than R. So what do you end up getting here? What's 30 over 1.7 become? What does 30 over 1.7 become? You guys have calculators.
17.647.
Okay, that's what we get for our answer. Now, what does this mean? The rate has to be what? In words, how would you say it? Georgia.
The rate has to be greater than 17.6
Units of?
miles per hour.
Yeah. So the rate needs to be at least 17.6 miles per hour. Here's a question for you. If you go faster than 17.6, is that okay? Because you'll make it in less time, right? You'll still be under the 2.5 hours. That's why it's greater than. That's why R is greater than 17.6. Because you could go faster than that, and you'll still make it in under 2.5 hours. But if you go slower than that, are you going to make it? No. That's why this is R is greater than 17.6. Okay, make sense of your answer.
Should it be greater than or equal to? Because then we can go 7.
Yeah, sorry. Well, let's see what the problem said. No, you know, it said less than 2.5 hours.
If you finish in 45 hours.
Yeah, if it said less than or equal to 2.5 hours, we would have done that. Absolutely. Okay? At least, or let's say, instead of at least then, I should change my words, right? Because at least means it could include that. We should say, well, we could just say more than or greater than, actually. Just make it easy. Okay, more than or greater than. Thank you for the correction. That's a good point. Again, if I had said at least, it could have meant 17.6 or greater, but that's not true. It needs to be bigger than that. So we'll say more than. More than. Good point. Good point. Before. So example 4 says Katherine's second test score was 8 points higher than her first. Her third was an 88. If she had a B average, which is between an 80 and 89 inclusive, meaning including those endpoints, for the 3 tests, what can you conclude about her first test score? Give me a given statement. What's my given or my let statement?
I'll let X equal her first test score.
Yeah, because that's what we're asking for. How many points higher was her second test score than her first?
8 points.
So it's X plus.
8.
And what's her third test?
8.
Given. 88. It's not even like a let statement for that part, right? And we know that the average of these 3 is between 80 and 89. How do you find average? Add them up and divide by? Yeah. So X plus 8 plus 88 all divided by? Everybody? 3. That's how you find an average. So this would be the average right here. The first test plus the second test plus the third over 3. And what are they between? What numbers?
80 and 89.
Yeah, 80 and 89, right? Were those the numbers I said? And we use less than or equal to. Please multiply by 3 on both sides. So this will be 240, and this will be 267, and then solve for x. Finish this over the weekend, please.